So we've added and subtracted polynomials. Let's look at multiplying them, and don't think that we've forgotten about division. That gets to come in a later section. But multiplying polynomials, we've already been doing that anytime that we had something where we FOIL. So I know this example isn't on your sheet, but we've been doing this already because each of these, x plus 1 and x minus 3, those are each polynomials. And to multiply those, we distribute, or we have a shortcut for this one called FOILing. And what we do is we just send each term in the first polynomial to each term in the second. So when we do our first, we're doing x times x. And when we do the outer, we're doing x times that negative 3. So we distribute each piece in that one to the other one. When we do the inner then, right, we distribute the 1 to the x, and then the last we distribute the 1 to the negative 3. Right, so we would have x squared minus 3x plus 1x minus 3, and we get x squared minus 2x minus 3. So we do this distribution step. That's the first thing, right? And then from there we just combine the like terms. And it's going to be the same thing going on, but we're just going to have more terms in each of them than just the two that we've seen when we can FOIL. And so what we're really going to be doing is FOILing, but FOIL doesn't work because we're going to have more than just first, outer, inner, last. We're going to have first, middle, outer, inner, middle, last. So you'd have to come up with some new funny acronym for that. And you can try to do that if you want. But let's look at these. So here we have 2x plus 3 times 3x squared plus 3x plus 5. Okay, so we're going to do the same thing that we've done before and take the first term and distribute it to each of the ones in the second term. Okay, so we would do 2x times 3x squared. That gives us 6x cubed. We send 2x to the middle. So 2x times 3x gives us 6x squared. And then we send 2x to the last term, so 2x times 5 is 10x. And here's where I want to give one little suggestion that helps keep things a little bit more organized. When we start sending the 3 to the other terms, instead of just adding those further on to this line and then having to look through everything to find like terms, we're going to instead line them up underneath. So when we send 3 to 3x squared, that's going to give us 9x squared, a positive 9x squared. So let's put that below the x squared that we already have. Okay, when we send 3 to the 3x, that's going to give us a positive 9x. And then 3 times the 5 at the end, that's plus 15. Okay, and now this is nice and organized. We can just add our like terms straight down and get an answer. And you can imagine that if this was over here, as we get to something that's maybe a little bit longer, it might be difficult to look through all of that and find your like terms when we get to some of the longer ones. So doing it like this helps keep it organized. We just add straight down, so we would have 6x cubed plus 15x squared plus 19x plus 15, and there we go. Okay. So it's really just distributing. It's the same as FOILing, but we have a little bit more to work with. Let's move on to the next example. So we have 3 of them this time. So we know that if we pick any 2 of these, we're going to get a quadratic, and then it's going to look like the one that we just did. So we could either do x minus 5 times x minus 1 first, and then multiply what we get by the x plus 2. We could do these 2 first, and then multiply what we get by x minus 5. If we really wanted, we could do the outside ones first, and then multiply what we get by x minus 1. I'm going to do these 2 first, just because for some reason I feel like it's simpler to leave the shorter thing in the beginning. I don't know why, that's how it seems to me. So we know on our next line we're going to have x minus 5 times whatever we get from multiplying these two in the middle. So here we have to FOIL, so we're going to have x squared. We would have plus 2x, right? So plus 2x minus an x, that's going to give us plus 1x. And then negative 1 times 2 is, so that's minus 2. So now that looks almost the same as the one that we just had. And we just have to distribute each term in the x minus 5 to each term in the second part, and we'll be good to go. So x times x squared gives us x cubed. Send the x to the x, so x times x is a positive x squared, and x times a negative 2 is going to be minus 2x. Time to send the negative 5. So negative 5 times x squared is going to be negative 5x squared. Negative 5 times positive x is going to be minus 5x. And negative 5 times negative 2 is going to be plus 10. And again, that keeps things nice and organized. We can add straight down, and we have x cubed minus 4x squared minus 7x plus 10. One last example, just a little bit bigger than either of the others that we've done. Now we just have 3 terms in each of them. So we start out by sending negative x squared to each term. So negative x squared times 3x squared is a negative 3x to the 4th. Send that to the second term. That's a positive 7x cubed. And send it to our third term, and that's going to give us a negative 6x squared. So we're done with that one. I'm going to do the 4x in red. So send 4x, excuse me, 4x to the first. That gives us 12, right, plus 12x cubed. Send that to the second term, and that gives us a minus 28x squared. Send that to the last, and 4x times 6 is going to be plus 24x, right? And again, see how we have things lined up and arranged, all in good order. And so lastly, sending the 3 to each of them. So 3 times 3x squared is a positive 9x squared. So let's put those below the other x squareds. Send it to the negative 7. 3 times negative 7x is going to be minus 21x. And sending it to the last, 3 times 6 is going to be a positive 18. I like the look of the orange on here. But anyway, add all this straight down. Negative 3x to the 4th plus 19x cubed. What do we got here? Minus negative 34 plus 9, so negative 25. Negative 25x squared plus 24 minus 21, so that's a positive 3x plus 18, all at the end. Okay. And so again, I think this is probably the one where we can best see how helpful it might be to keep those arranged. Because let's look at this. If we did have this all in one line, first off, you probably don't even fit this all in one line on your page. It's probably going to all run off like it does there. And then try looking through that, and you've got x to the 4th. You've got to scan all the way through here. Do I have any other x to the 4th? No. Okay. We would have 7x cubed. Where are all my other x cubes? There's one there. And I think I should have another one, don't I? No, just a 2. So you can see how tedious that might be to put it all on one line. It'd be easy to miss something. So again, I think best way to go is keep it nice and organized on top of each other, kind of like that. All right.